Okay, hello, welcome very much to our second industry. It's Eden Campus Industry Club. As you may have guessed, we're very keen to engage with all types of energy, and in particular lithium-ion and rechargeable batteries and hydrogen and fuel cells. So, and it's really important that we can get these communities working together and learning by each other. So today I'm very pleased to have two talks, one from Arcolo Energy and one from Impact Solutions about hydrogen fuel cell powertrains and about batteries. So I'm going to invite, first of all, invite Stephen Burns from Impact Solutions to present our involvement in the safety and sustainability of lithium batteries. Steve, over to you. Thank you.
Hi there, good afternoon.
Okay, thank you. We can see and hear you. That's great.
Fantastic. Thanks very much. So, as introduced from Impact Solutions, my name's Stephen Burns, and I'm going to talk to you today about our activities looking at safety and sustainability, in particular of lithium-ion batteries. So, to start with, probably best to explain a bit about who we are, as we're not particularly well known in the battery space. Impact Solutions was formed as a management buyout in 2002 from BP Chemicals R&D department. And over the last 20 years, we've really focused on material development, consultancy, and especially innovations around new sustainable technologies. And certainly in the last 5 to 10 years, we've focused very closely on upcoming energy technologies and especially around lithium batteries. There's an awful lot of development that is required as the technology is scaled across industry. So, as I said, we've focused very much in the past on material development, but also in the technology development and process development, and I'll talk to you today about a number of projects which we've undertaken recently and over the last 5 years. Our business focus is really on innovation and performing innovation, both for ourselves, where we look to develop new technologies and spin out businesses as joint ventures with the partnerships we form. But we also do a lot of R&D, contract R&D for many large multinationals across a wide range of technologies, whether it's for energy storage, whether it's for material development, or for other areas of technology development. So the first project to talk to you today about was a project which we took part in over a number of years. The project was called Saboteur, and it was a project funded by the European Commission and had a number of European partners. And this project was very much looking at the safety of lithium-ion batteries, especially when transported on cargo and passenger aircraft. I'm sure many of you are aware it's very difficult at the moment to transport lithium batteries by air. There's been a number of safety concerns while in transport, and agencies like the FAA in the US and EASA in Europe have put in place fairly strict regulations on how a lithium battery can be transported. So we took part in an extensive evaluation of the current methods used to transport lithium batteries, but we also looked into developing a testing methodology and a way to mitigate the effects of safety concerns of lithium batteries while we do the project. And that project has really moved on post-project. We're now part of a SAE committee, which is developing a standard which will allow packaging companies to develop packages which will safely contain lithium batteries when they're in transport, and allowed them really to go back onto passenger aircraft and the vast majority of cargo aircraft. So our role in the project was really looking at trying to model the effect of the fire or the thermal runaway events you get when a lithium battery becomes damaged and releases its energy. So the pictures on the left-hand side just shows one of the test setups we had. You can see hopefully that there's a label saying initiation cell, and that was the cell that we were driving into various states of thermal runaway, and we were then looking at the peak temperatures we got, we were looking at how much gas was generated as a result, and we were looking at what damage that would do to the surrounding packaging, but also what effect that would have on a actual aircraft while in flight. And we modeled, we ran simulations quite extensively throughout the project, looking at a variety of different factors which would change the way the cell went into thermal runaway, and we were then looking at introducing mitigation methods to try and reduce the effect of that thermal runaway. And you can see on the right hand side there's various graphs there. The one in the top left shows a fairly typical trace. These are temperature readings over time, and to anyone who's ever set a cell or seen the effect of a cell going into thermal runaway, you can get quite a vicious explosion. You get a very large amount of heat produced, and that heat jumps to the neighboring cell, which causes that cell to also go into a thermal runaway, which is one of the problems with transporting the cells. But we looked at a number of different mitigations, different temperatures, different pressures, different way of packaging cells, and we looked then at the physical results of what that meant in terms of thermal runaway. And you can see the graph at the bottom. You can see it's a much lower temperature. There's not temperatures going all over the place, and therefore the effect of the thermal runaway was much lower and much less severe. And all that work then went into developing with our partners, one of the Belgian research institutes, a thermal model of what happens within a package of cells when one of them enters thermal runaway, and what can then be done to the packaging to stop the thermal runaway and therefore protect the aircraft that's transporting the cells. So from the data we initially produced, a thermal model was built, and then various different scenarios were put through that model where we were then able to validate the model was working correctly. And that model is now being used by various companies who are developing packaging to look at how they can develop the packaging to allow the transportation. And this experience we had developing test methods for setting batteries into thermal runaway has really been quite valuable to us as a company. We've talked to a lot of people in the space, and there's not that many companies who will purposely try and damage a lithium battery and look at what happens. And we've become quite good at both controlling how the lithium battery goes into thermal runaway, which means we can help companies like the automotive OEMs, the car manufacturers, develop better materials to surround their batteries, increase the safety, but also the longevity. So we've undertaken a lot of work now for a number of different UK-based car manufacturers who are now looking at putting into place their electric vehicles, and they're looking at the different materials they can use to package the batteries, both from a safety point of view to protect those in the vehicles, but also to increase the longevity of the batteries. So we've developed a number of test methods to allow different scenarios to be run on what may happen to the batteries in use. So one of them that we've run for a number of companies now is looking at collecting the cell gas produced from the batteries. And that cell gas can then be used to condition the materials that they wish to test or they wish to develop, and look at what effect that cell gas has over a elevated time period on the material itself, whether that's looking at, in the case here on this slide, looking at what the fire performance of the material would be if it had been exposed to cell gas over a long time period. But we've also looked at things like the mechanical properties, the tensile strength, and also just the chemical compatibility of different materials with different batteries and the different types of batteries, because obviously they produce different gases when they go into when they get damaged and they go into thermal runaway. So coming on to next project, and again, this has been very closely tied with the development we've had throughout the projects we've been running. And this is looking at developing a diagnostic tool which can prevent a lithium battery ever getting to the stage where it does enter a thermal runaway event. It's a technology which has been developed with one of our partners, Algolion, who are based in Israel, and they've developed a technology which can look at whether a cell is starting to display damages or changes to the electrode structures which are a precursor of the thermal runaway events or the damage. And they've been fairly successful at proving that this technology works in a way that is useful to industry. And what we're now trying to do with Algolion is we're looking to take this one step further. Instead of saying, well, we now know that cell is damaged and is going to go into thermal runaway, we're looking at developing it to allow batteries to be driven a lot harder over time without causing the changes in the electrode state or the material state, which causes them to lose charge over time or go into a state where they're dangerous. And that project is currently ongoing. We're working with St Andrews University on this as well, and we hope to have some results on this by the end of 2021. And then the final project for me to discuss today is a project that really builds on the knowledge we've built up as a company in different industry areas. And one of those is plastic recycling, where we've developed a number of different patented technologies which have been introduced to industry and are now being used throughout the world in plastic recycling. One of these has looked at using novel solvents to selectively dissolve metallic pigments which are used in the coloring of plastics. And we're now in the early stage of development of converting this technology to be able to selectively dissolve the different metals that you would find within a lithium battery. We're working with a company called EcoSurety. They're one of the UK compliance schemes, including for batteries, for waste batteries. And we're looking at how we can convert the technology from the plastic recycling industry into a technology which is suitable to be used in the recycling of lithium ion cells, which, as electric vehicles become more and more used and more important, they're going to be a much bigger demand for the recovery of these type of materials, especially things like cobalt, which is already becoming a problem in the supply chains. Now, CellMine is a very early stage technology. For those familiar with TRL levels, we're really in the infancy in TRL3, around TRL3 at the moment. And we hope by the end of this year to be in a place where we'll have completed the initial feasibility and be able to start looking at how we develop the technology and start to integrate it into the recycling chains for batteries. And we're happy to talk with partners who may be interested in this area, because we're very much about collaborating and working with others to find the final solution. So thank you very much for listening. I hope that was interesting to you all. Very happy to take questions, and if anyone wants to contact me directly, my details are there.
Thank you. Thank you very much. So,
John, I've had one question through already for Steve, and if I could just jump in with that, if that's okay.
No, please, this is your bit. This is your event, Ian. So.
Steve, we had a question from Jerry. Have you done any shock tube testing to see if released gases have flame front acceleration or detonation potential? I hope that makes sense to you, because it doesn't all make sense to me.
It makes sense to me, but no, we haven't looked at that at present. We've looked at the gases, we've analysed the gases fairly significantly on things like GCMS, but we haven't gone to the stage of looking at the explosive properties or how they actually combust. As part of the project, the Saboteur project, Airbus did carry out some full-scale testing with, top of my head, I think they had 960 cells which were placed into a old Airbus aircraft out in Germany, and they did look at the effect of the explosion on the body of the aircraft itself, but we didn't do any analytical work on the actual flame or detonation potentials.
Right, thank you very much. No more questions at the moment, John, if you want to carry on.
Yeah, just a quick question on the recycling. How do you disassemble the cells? Probably in relation to the explosion question.
Yeah, well, at the moment, the project is really looking at the feasibility of whether the technology we've developed for plastic recycling is going to be able to selectively dissolve the metals that we want to dissolve, especially the cobalt is one of the more valuable ones. And that's really then looking at trying to say, well, are we recovering them and can we recover them in the correct form? If we find that that is feasible, the other aspects of the process, one of which, of course, is how do we disassemble them? And that disassembly will have to be suited to the disassembly that our process would require. So,
yeah. Obviously, Birmingham University are developing robots for disassembling batteries, so it's not. I was just wondering if you had that in mind.
Yeah.
I know it's doable.
Yeah, no, it's certainly something we have in mind, and we're aware of there's various different companies. There's a company we're aware of in America who's got a process. There's a company we're aware of in Australia who have a process, and I believe there's a couple of German companies who have various processes for disassembly. So we know it can be done. So we're trying to focus on the challenge we see, which is can we actually recover the metals first and foremost.
Yeah, it's better than using brave PhD students. Okay, many thanks. So there's more questions. There'll be a question and answer session at the end, and hopefully we can tie things together on and get cross-linking questions as well as specific questions there. So moving on to hydrogen, and I'm very pleased to welcome Ben Todd to speak to us on hydrogen fuel cell powertrains for heavy vehicles. Ben is CEO of Arcolo Energy, and look forward to hearing you, Ben.
Thanks, John. Thanks everyone for having me. Trust you can hear me okay. Somebody send me a WhatsApp if you can't. Yeah, so really nice to be talking with you. I'm going to give, I guess, a slightly different style of presentation now. Obviously, you've heard there about some very specifics. I guess I'm going to go slightly broader. So in some sense, we sit at, I guess, a different part of the market. So Arcolo Energy is an integrator, and we effectively put things together. So yeah, we're delighted when people make the components that go into our vehicles safer and more practical to get them where we need them to be. So brilliant. But yeah, this is the end of, I suppose, looking at the end customer. So Arcolo Energy, I guess some of you know Arcolo. So we're a specialist in hydrogen fuel cell system integration. And our real focus, we've done all kinds of things over the years, but the real focus now is on zero emission heavy duty vehicles, so buses, trucks, trains, that kind of thing. So I'm going to talk a little bit about kind of what we do, get a bit into the technology platform and a bit into the kind of route to market and some of the challenges with that. So I'll rattle through quite quickly, and obviously happy to take questions afterwards. So yeah, see ourselves as kind of systems engineering company. I'd resist becoming a consultancy because I first actually do stuff and make stuff. But we've got that kind of caliber of people. I'm moving into this kind of tier one, so that OEM make cars. Tier ones are the kind of the first level of the supply chain into vehicle manufacturers, and in some cases, because the market dynamics actually acting as that vehicle supplier, really as a route to market to pull through what we do in hydrogen fuel cells and batteries. I'm assuming all the people on this call are well aware of the parallels between fuel cells and batteries, and the fact that it's pretty daft when people say that they should compete and fight against each other. They're complementary, and you put the right thing in the right place and the world's a better place. So that's very much our interest. I'll skip through probably most of the rest of this, but yeah, collaboration is key. I have a PhD in high temperature fuel cells, and so that understanding from catalyst to fleet, I think, is in this early stage in the market where I think you need to be to do it right. And again, in a way, touching on some of the issues raised in that previous presentation, properly understanding what's going on that's going to affect the safety and the viability of product, we think is really important. Buying stuff off the shelf by people that don't really know what's in the box isn't a good thing for us to be doing right now. So another kind of picture of where we sit, we still have to deal with this kind of market creation piece, creating products to actually creating markets to bring product to market. Where we really want to spend our time at the moment is around product development and just starting to move into manufacture. And kind of the dream is to get into that aftermarket piece, which is then where you get to close the loop by both doing technology development, product development, manufacture and aftermarket support. We can capture that learning and go round and round the loop. So kind of bottom right, we started out down in London in Hackney. We've got a new facility in London as well, small space, really for COVID security, give our staff more options for working. So that's in Enfield in London. On the left there's Bowness, so that's our rail facility. We've got a big train project on at the moment, so we're kind of camping out in Bowness and Kinneil Railway. They've been very kind to give us some space and use of some of their facilities. And I guess given the conversation with St Andrews, Dundee. So this is not yet official. It should be in a couple of weeks. But I think lots of people know that we're planning to come to Dundee and open a manufacturing, engineering and sort of aftermarket facility up on the innovation park, working hopefully with various people that are on this call. So a bit in terms of timeline for us, yeah, we've been doing this I've been in fuel cells the best part of 20 years, give or take. But yeah, we've worked our way through, I suppose, from smaller vehicles up to larger vehicles. And we're really starting to see this traction. So the kind of right-hand side of this slide deck, the kind of common factor here is that a bus is about 18 tons, a bin lorry is about 26 tons, and a train is a series of roughly 20 to 30 ton lumps all joined together. So that kind of scale is the space we're interested in. Why do we do this? Why do we electrify? Obviously, acceleration is better than diesel, whether you're battery or fuel cell. Electrification is the win. Plus, of course, you eliminate the local emissions as long as you electrify. Greater efficiency overall. That's just baseline efficiency. Not worrying about where you get your hydrogen from. Obviously, what we're interested in then is obviously green hydrogen to fully take out the emissions, both local and remote. The difference, if you like, from batteries with fuel cells, you're dispensing a hydrogen fuel, so you get fast fill. Good efficiency. If you do your engineering right, you get to good efficiency, and it gives you that full day zero emission range. Something we think is really important, and this is, I guess, into the nuances of doing it well, is if you get the thermal integration right, you can do quite a lot to improve that efficiency penalty you take by taking electricity to hydrogen and back to electricity again. If we can recover a chunk of that heat and use it on board, obviously in the winter, less so in the summer, that you get your overall efficiency to a better place. So if we think then in terms of how we deploy this, so we deploy it in refuse collection vehicles. This is a current live project. We're doing the first vehicle over in Glasgow at the moment. And yeah, similar to the buses, you get to operate fully zero emissions range. You can do the full run, up quite easily double shift the vehicles. In fact, so you get better use of vehicles. You don't get that kind of wind down in performance towards the end of the day. We can get to the full payload. You can take it out on the motorway if you need to. So there's a load of areas where people are looking at putting battery powered refuse collection vehicles. Brilliant, get on with it. And there's areas where it won't work. You've got fleet managers saying, well, it just won't do it. I don't trust it. And that's where we step in with the fuel cell solution to give that longer range. The kind of aftermarket piece there, I suppose, yeah, being critical. So the real tech bit then, I guess I've touched on some of it, but we consider the whole vehicle as being within our scope. We'll partner up with different people in different areas, but getting that whole piece together is what we think makes the difference. So actually starting at the top, the control and the safety systems, so from the driver all the way to the wheel, understanding that control flow right through, we think is critical. So yeah, starting with the hydrogen. So hydrogen tanks that we size for the total energy required on a given day. into the fuel cell system, which is sized for the average power consumption through the day. So the fuel cell isn't a range extender, it's providing your full range, but it's not providing your peak. So over on the right there is the battery, which we size for peak power. So regen, which is obviously critical to overall efficiency, and also of course acceleration. So setting up the right balance of system is where we spend a lot of our time. Yeah, rubbish in, rubbish out kind of approach. Yeah, properly understanding what people are trying to do. Into then, I guess once you get into the middle, then it's common whether you're running a battery vehicle or a fuel cell vehicle. Again, for those less up to speed on the area, a fuel cell vehicle is essentially an electric vehicle with a fuel cell as the ultimate source of energy. But all of that work that's been done over the last few decades on delivering battery electric vehicles carries across and is really beneficial to fuel cells. It's probably just a different battery chemistry. So we look at using lithium titanate at the moment, which is almost into supercap. So it's a power battery, not an energy battery. Bit around our approach to the market, which is create this powertrain platform. So there's the platform kind of schematic laid out for a refuse collection vehicle. It's a pretty similar package of equipment for a train and similarly for a bus. So it's around the control piece, and really it's the safety and compliance is the bit where we think we add a lot of value. We look at a lot of the vehicles on the road at the moment, and I would argue that they probably shouldn't be on the road because people haven't really gone into that understanding of the safety case, both physical packaging and ultimately the control system. So kind of schematically then, how do we think about it? The equipment within this grey central box, the equipment, let's turn this pointer on. So these elements around the outside, we don't make. We're reliant on a global supply chain, and as a principle, we will always try and localize our supply chain. So looking to grow, really good hydrogen storage technology companies. There's one in particular in Scotland that we're developing a relationship with. Fuel cell systems at the moment, typically it'd be Ballards are coming in from Canada, but some of you obviously will be aware of UK and more local fuel cell companies coming to market. Batteries, there's some really interesting work going on, particularly in Scotland on batteries, and well, everywhere at the moment. So obviously, who hasn't got a gigafactory? But again, that interest in power batteries. So we typically use about 1/10 of the amount of battery capacity on a fuel cell vehicle as you would on a battery only vehicle, as a kind of crude metric. So it's a lot less battery, but it's a critical part of the component of the system. And then let's say the more conventional, but actually utterly critical, of course, elements of thermal management and the power electronics and so on. The bit that then actually brings it to market and makes things happen, we think, is all this stuff artistically laid out as the wheels on the vehicle. That modelling and simulation piece we talked about, replacing diesel is fundamentally really difficult. Diesel was kind of God's gift to us with an unfortunate barb in the tail. When you displace diesel, you find that people typically don't really know what it is they're trying to do. They haven't got a proper understanding, regardless of what they tell you, of the duty cycle, of their power requirements, their energy requirements. So that piece is a kind of critical front-end activity. Seems obvious, but it's too often not done well. And then getting into the vehicle integration, where do you put it? What are the trade-offs we need to make around packaging volumes, about physical strength, around where you put the different components, and some really interesting nuances with people like Jerry, who's on this call now, asking, if you like, that those tricky questions that are well beyond the spec sheet. If we're going to put these things out at volume, we need to be getting to much higher levels of inherent safety than you get if you bolt the bits together, of which obviously leads you then to the functional safety. The regulations, codes and standards piece, I think, is really interesting because it's an awful lot better than it was 10 years ago, in the sense that there are a lot of codes and standards, but we'd say almost on the certification there's still a gap. So there is, if you look around for it, you can find really good practice on how you should be doing things. You still need to interpret it, but actually we're seeing that the capabilities in the certification agencies to ensure that every vehicle that hits the road in the UK or somewhere else has actually implemented that best practice, we would say is still quite weak. So there's some really interesting work, I think, that's going to, I certainly hope it's going to accelerate quite quickly. I know it is in Scotland, to figure out how to join all this stuff together. So I'll just jump quickly over the kind of, in fact, I'll skip over modelling. I've probably talked about that enough, but yeah, we've got a nice proprietary modelling package that takes you from what's going on through to the control of the the components, the devices, subsystems within the vehicle, which then obviously then feeds into the ultimate control system on the vehicle. So it's the kind of obviously hardware in a loop type approach. I thought maybe this is fun to put in, just a kind of a battery electric vehicle plus fuel cells and hydrogen doesn't give you a fuel cell electric vehicle. So battery vehicles have got very carefully chosen batteries and architectures that work really, really nicely as a battery vehicle. You stick a fuel cell on top, you're basically not optimizing it the way you should. So just those three, obviously they're somewhat arbitrary, not arbitrary, they're specific duty cycles that we've chosen to kind of illustrate what, if you get your balance of battery and fuel cell right, where you get your wins. So touch on engineering. Hopefully this is obvious to, well, those of you that are in industry, something that kind of bugbear for us really of people coming out of university, I guess, to those of you in academia. If you could help us by beating systems engineering into your students, that'd be really helpful. So the understanding that you really do need to properly define what it is you're making, how you're going to take all of those requirements down into the hardware and software, and how you're going to validate it on the way back up. Certainly for myself coming from academia, it's been quite a hard lesson to get my head around exactly how you do this and how you build a company that does it. And it's kind of, well, it is very definitely an obsession that works well. So that, again, showing off really. Some nice certificates, but critical, we think, in getting all of these systems and processes worked right through. You suddenly start playing with batteries, actually implementing battery safety and fuel cell and hydrogen safety in a working environment is non-trivial and needs to be done properly. Here's a bit of fun then, I suppose, around moving from sectors. So we've spent a lot of time working in buses, moving into trucks, and actually now working in rail. And on the large picture there is a rail system engineering kind of safety life cycle, which is following a V. And this mapping, as we move technologies between sectors, I guess you touched on again the previous presentation, the safety considerations in putting batteries on aircraft are really quite specific. And there's a regulatory regime in aircraft and in rail, in fact, which both very, very good. But you introduce a new tech into that regime, and it's really non-trivial to work out how to line it up to deliver projects, particularly under the usual time and commercial pressures we're all under, that carry through that compliance work. So if you like, I'm not talking about the technical specifics, but actually the project delivery, the engineering team alliance, the partnership and collaboration that will put things on the road, on the rails, in the air, that are done right. And this is really getting, I suppose, into some tech. Just the general concept of functional safety. We find talking in different industries, automotive is kind of obsessed with ISO 26262. Those of you who know automotive will know that most of the vehicles on the road are not fully compliant with it. Some people argue that you can't be. So that's the automotive functional safety. We move into rail and there's a different one. But these families of compliance approaches apply, whether it's the machinery directive or 26262. But linking them together, these notes are from a guy called Stephen Hughes, really good safety engineer at Abbott Risk Consulting over in Edinburgh. How you join those different cultures together, how you understand the framework. This comment's quite a long comment on the left there, where there are these increasingly complex structures that you might look to use, and we're tending to find in every industry we work in that people will say, oh, well, it's clear, you're in rail, therefore you need to follow this. And actually tends not to be true. And in automotive, which you would think of as a much more established market, and in high volume automotive, I think it probably is, but in these lower volume niche market, actually the regulatory frameworks are really complicated. We spend a lot of time working with the regulators, and over the course of a 3-year project, you'll find that we'll speak to 3 different agencies with 3 different approaches to actually get to market. So the practicality, never mind the technicality of how you get to safe vehicles, shall we say, in the broader sense, is really non-trivial. Skip over a bit of powertrain. So I think we're back into our approach. This, I think, is a picture we put together a long time ago, thinking about how we work with this was working with an OEM. So on the left in grey is that kind of base vehicle, whether it's a bus, a truck, or a train. Somebody somewhere spent a lot of time figuring out how to make them. They've got a well-established team. And on the right is then the Arcola team. We're up to about best part 50 people now. So we can actually have several individuals in each of these boxes in the early days, we'd have, more than one person covering more than one box. But whatever the setup, that understanding that every single one of these needs to be covered, well, you simply don't, you can't deliver quality and compliance if you don't go through that discipline. And I think as we move out of this still very early stage in hydrogen and fuel cells into more vehicles, therefore inherently more risk, getting this stuff right is going to be really, really tricky as new companies come to market. So in the end, you model it, you build it. Yeah, I won't go into the nuance of it. Yeah, some of the thinking in the hydrogen systems. Maybe it's useful saying, there is a very well-defined set of technical requirements for putting hydrogen cylinders and storage systems into vehicles. But there's some very straightforward, and everybody goes, right, EC79. So there's the tank compliant and there's the setup compliant, and you've done your FEA. But there's a whole load of other considerations around effective venting and where the hydrogen might go if it leaks or doesn't leak, which is far less well defined. I think I'm slightly running out of time, so I'll go a bit quicker. Just touch on how you make that decision around whether it's a fuel cell vehicle or it's a battery vehicle. What are the trade-offs you make in terms of the convenience of batteries, the convenience of hydrogen as a fuel. There is an interesting distinction between the two. There's quite a big overlap, and as the market evolves, we should start to see less kind of petty squabbling and more of a kind of, well, is it petrol or is it diesel? Is it battery? Is it hydrogen? And it will start to become more clear. Skip over that one. And maybe this is maybe a useful one again as we kind of move to market. The understanding of where things are hard and difficult. So we look at it as typically we're trying to get fuel cell projects, hydrogen projects to happen. So the stuff on the right, and very much people go, well, when we're moving into battery electric, we got one. The supplier gave us one. It was relatively easy to get an electrician to give us a socket to plug it in, and off we went. We had a go, tested it, pretty happy with it. Now we're buying loads. In fuel cells and hydrogen, they go, so can you send me one? And you go, no, because it's actually really difficult to supply one bus in any kind of cost-effective manner, or even 10 is pretty tricky. But then when you get to doing a full depot battery electric bus conversion is really quite hard work, let's say. It's clearly doable, but it's hard work. Doing a full depot hydrogen bus conversion is actually much more straightforward. So getting the market to understand the different challenges with the different technologies, approach them in the right way. And I think we're going to see more and more understanding of where the risks are. The insurance industry is going to get really important in this as we start to have not just the kind of nonsense on the internet talking about battery vehicles on fire, which is hype and nonsense mainly, but actually the proper understanding of what the long-term risks are at the fleet scale, and then how that will cascade back into the engineering requirements to know, are people willing to insure that particular battery vehicle, that particular hydrogen vehicle, because they've understood the total loss cost of knocking out a fleet is tens of millions, never mind risk to life. So yeah, final bit really, maybe a successful deployment. There's the engineering piece. There's working out the fuel. Obviously, ideally, we want that green, sustainable, overall green approach. But the fleet support piece then is critical, and we think of fleet support as feeding back into the tech, kind of closing that loop. Plus, obviously, a financial model, always a joy. Trying to defeat diesel, which is cheap and very well developed, gives you a proper customer proposition. I'll skip over how you do that, and maybe I'll just leave this on screen. As I say, I'll stop there. Nice talking to you. Very happy to talk to people about questions, issues, and how we might work with people. Cheers.
Right, thanks, Ben. Okay,
fantastic. Thank you. Okay, Colin, do you want me just to take the questions now? Okay, superb. Ben, Stephen, both really good presentations, and interesting that although ostensibly you come from different bits of the sector, as it were, I think there's some quite interesting connections in some of the things you were talking about. So maybe we'll pick some of that up in the discussion afterwards. I've had a few specific questions. I'll start with you, Ben, if I could. Somebody said it's a slight side conversation, but what are your thoughts on biomethane solutions for heavy vehicles compared to that of hydrogen? And I think it probably touches on some of your comments about how diesel might have been God's gift, but we need to be finding alternatives to it. So biomethane, how does that compare to hydrogen for heavy vehicles?
So I guess my first answer on most of these things is we need all of them. And the idea that one displaces the other, I think, isn't true. So fundamentally, biomethane, if it is, assuming you've managed the bio element, and you're obviously not slashing and burning rainforest in order to create it, but you're taking it from waste cooking oil or something like that, then you've got a genuine carbon saving, which is good. So 10 out of 10 if you do that right. Absolutely happy. Same challenge exactly as you would with electricity or hydrogen. Where'd you get it from? What's the ultimate source? I guess at the street level, anything where you're burning hydrocarbons close by where people live, eat, shop, walk down the street, go to school, you've got a fundamental issue. So moving to a biogas won't resolve that at the vehicle level. And I think there's also a bit of looking at it. There's a limited amount of genuinely sustainable biofuels. My preference would be to put them into places that are even more difficult to do with battery or hydrogen. So aviation would be a classic one. Yeah, but the point at which we can do long haul aviation using hydrogen or battery is either a long way away or never going to happen. So that's a good place to use your biofuels, not necessarily as a gas, but the synthetic or biofuels.
Brilliant. That was really helpful. Thank you. Really thoughtful response. Another question we've had is a bit more technical about, I mean, you did in your presentation, you touched on safety issues and adherence to safety standards. Somebody's asked, what is your stance on the hydrogen, on your safety stance on the hydrogen provision for vehicles, i.e., where is the hydrogen coming from? How much do we need of it for a given day or vehicle, and so on? Oh, sorry, that's not specifically about safety, but that's specifically about the hydrogen supply, and I guess to some extent, how concerned are you with the source of your hydrogen and the quantities that one might need to transition to a hydrogen economy?
Yeah. Okay. So within that question at the moment, I guess that question's become a lot more prominent at the moment because hydrogen's hot again. The world's gone mad for hydrogen, and having watched a few of these hype cycles now, the problem is when the world goes mad for hydrogen is you get a lot of charlatans talking a lot of rubbish, and that really agitates, quite rightly, a lot of people because they pretend hydrogen's going to do everything. So the key, just like biofuels, where you get the hydrogen from is critical. To get that wrong, and you're basically wasting your time. You're just squandering energy needlessly. So the sourcing is important. As a small company, not doing we're going to do a SPAC and become a $53 trillion company overnight. I'm less interested in that kind of highfalutin nonsense politics. So we would look at it as our role in this market is to try to get technology into vehicles, onto the road safely and properly. We would, as a company, we would run projects where we're buying sort of brown, grey, some of those less fun shades of hydrogen, because we'd see it as a way of getting things on the road and having a local air quality benefit, even if we're not necessarily delivering the carbon emissions saving that we want. So we would tolerate it in the short term. But the projects that are really interesting to us are the ones where, which is why Scotland's so interesting, where you've got a latent capacity to build out more renewables. And we know of lots of big schemes that could be built tomorrow, could have been built 5 years ago. If somebody was able to put together the commercial structures, the power purchase agreement with sufficient solidity, understanding and guarantees of offtake, but they don't exist. So we're not building renewables that we should be building because we can't make the market work. So if you can make hydrogen fuel cell projects work that basically enable and unlock that capacity, then that's a good thing to do. So I'd like, as with everything else, I'd like to think that cradle to grave route. And I'd definitely say, yeah, if it looks like nonsense, it probably is. We're in a hype cycle.
I'm going to quote you on that on a regular basis. Ben says, if it looks like nonsense, it probably is. It's going to be the strap line on all my presentations from now on. I've got a question here that kind of touches on a similar area. Somebody's asked, how does hydrogen generation help power requirements to a bus garage? Do we still need the megawatts in? And I guess that is a question to some extent about system integration, isn't it? About, you know, the extent to which we're thinking about this as isolated systems or connected systems.
Yeah, so the key with this is and to a certain extent it applies to battery charging as well. Yeah, where is it that you apply, you transfer the energy from, if you like, land to vehicle? So if with batteries, typically to get the amount of energy you need in, you're going to do it on depot. So it's on depot-based charging. We can do opportunity charging, this kind of thing, but generally, if you want your batteries to last and you want it, you're going to be doing depot-based charging. With hydrogen, you've got a couple of choices. So you can keep your existing depot operation, which is the buses come in at the end of the night, they get washed and cleaned and all that kind of stuff, and then they trundle off to the diesel pump, get filled up with diesel, and they get parked. You could do that with a hydrogen refueler on site at the depot. And that hydrogen fuel could be tankered in like the diesel is, in which case if you've got no energy demand local to the depot, you're tankering in your energy, not running it through a pipe or a wire. You could make that hydrogen on site by electrolysis, in which case, like the batteries, you're wiring, you're bringing your energy in on a cable. You'll get a slight difference in the sense that you can run the electrolyzer during the day when the buses are out and overnight when the buses are in. And you can do load. You can use it as a dispatchable load or a turn downable load, but you're relatively similar to batteries in the sense that you're going to manage the grid load. So maybe you need half as much if you go with electrolysis, except your efficiency is lower. So if you're doing on-site electrolysis, you've probably not got that much of a difference. But the other bit you could do with hydrogen is you really can, if you like, opportunity fill. So you can have buses at a depot. You don't onboard your energy at the depot. The buses fill up at an external station in some convenient location where you've either got a very big wire or direct access to fuel supply.
Great, good response. Thank you. Somebody's asked a question. Say a systems engineer. He's pointed out he's a systems engineer. Interested to hear your thoughts on the benefits of this methodology in practice. It would be great to understand more about what level of requirements can be viewed as transferable between transport sectors. Do you think there's enough collaboration between different OEMs and operators on developing shared building blocks for different hydrogen applications in R&D and supply chain development?
There's a long question.
Yeah,
I've got 50 colleagues who've got a view on that. So I didn't answer it. I get there's the kind of flippant answer, which no, more collaboration, more alignment would always be good. The more nuanced answer, I suppose, is so we take a platform approach. So we're looking to use essentially the same platform, bus, truck, and train. I see benefits at the moment in the fact that you have got these different approaches because we're interested in learning and growing our capability. So the learning that we picked up from bus on how to do buses safely, when you're thinking, well, I've got 100 passengers on there and kids smoking on the back seat, the safety considerations you build there, we then carry that into truck where, you know, typically don't have 100 people and kids smoking on the back seat. You've got different sets of considerations. So we're trying to capture the learning from that, and then obviously carry it onto trains where, you know, I think people smoke on trains a bit less, but yeah, that's similar, a different set of requirements. And in rail people think in terms of a system of systems approach. So when you design a rail system, you think about the vehicle and the fuel, and then from an EMC perspective, you think about the vehicle's got metal wheels on a metal track, and the signaling and stuff links the wheels to the track to the propulsion system, and you've got crazy harmonics all over the place. I think at this point, we find it really beneficial to capture all the kind of interesting, difficult challenges from that and pull it forward. So as we kind of creep towards greater levels of autonomy in vehicles, so road vehicles, we will have to creep towards a greater level of systems thinking, a la rail. So I think if you're to try to mandate a way of making all those regulations align, we'd all just go mad. It's hard enough doing it in any one given sector. But sharing the learning, I think, is beneficial. And you'll find, obviously we do it, we've got people from all those different sectors collaborating. We find in the big consultancies, so your Ricardos and your AVL, you'll see a similar thing for people working in rail that come out of automotive and so on. Yeah, I don't know if it's a very long question. I don't know if that's a useful answer. I'll stop there.
I think there's some very interesting points there about extending the sector. And it brings me on to a question that somebody's posted for Stephen, which, although a slightly different topic, I think there is an interesting point here about the extent to which we view this as a very large and integrated set of solutions. The question, Stephen, is, can designing safer cells lead to more recyclable cells too? Or do they pull in different directions?
Yeah, and it is quite an interesting question, that, Ian, and I think it ties in very closely with what Ben said in terms of collaboration between different industries. We've really started looking at lithium batteries based on the experience we have in plastic recycling, and plastic recycling has been something that has become a big news story really in the last 5 years as consumers have woken up to the fact that the world does actually have a problem with the amount of plastic we're creating. Until 2015, there was very little done on plastic recycling. There was very little technology development, which is why the world is really in the place it is today. And there was never any joined up thinking between those who were creating packaging or those who were creating products, really talking with the recycling industry about how they're actually going to recycle those and how are they actually then going to return that plastic to the supply chains. And even now, even though there's a lot of discussion about it, there isn't still the joined up thinking where manufacturers will work with recyclers to make sure things that are going into the marketplace are actually recyclable. And it drives me crazy on a daily basis seeing news stories about the next wonderful packaging solution that Coca-Cola or another company has come up with, and I sit there and go, but it's totally unrecyclable. And the PET bottle they had on the shelf yesterday was 100% recyclable. And it leads into battery recycling as well. As technology changes with lithium batteries, it is going to affect the recyclability, and it's going to affect the processes that are being created to recycle those materials. In recycling, you rely on having large volumes of a material that fits your process. And if the material that is being supplied to you changes in specification, in most cases, your whole process becomes redundant. And therefore, it's very important to have those who are designing and making cells working very closely with those who are going to recover them and return the material back to those who are then going to make new cells out of them. Doesn't necessarily, the question was talking about safer cells leading to be more recyclable. They don't necessarily work together for the same reasons. It's more important that the cell is designed in a way that the recycler can deal with it, whether that's from how do we disassemble the cell or whether that's from how do we recover the metals in that cell.
Great, thank you. And I might pull in John Irvine there if I could, because John, you're leading a lot of work on new battery chemistries, and it'd be interesting if you've got any comment on the extent to which recyclability is part of that conversation.
Yeah, I had a discussion yesterday with Recycling Scotland, so I'll get in touch with Stephen about that, because yeah, recycling is really important. We're developing sodium-ion batteries, which are cheap, and that's their key selling point. So it's not really so worthwhile recycling those, whereas the lithium cobalt ones with lots of expensive and unpleasant cobalt, there's much more value to recycle those. So, and I think the biggest problem with recycling batteries is the chemistries are very diverse. So you really need you're recycling one battery type at a time, and there isn't really a consistent design across the different manufacturers that would help the recyclers. So,
yeah, sorry.
Yes,
just to come in there on that point that John made about the value, and that's very much the case in the recycling industry. I've always been of the opinion that just about anything is recyclable. It comes down to whether it's cost effective to recycle it or not. And when you're talking about cobalt, there is a large economic benefit from recovering that material. Whereas if it's a lesser valuable metal, then there's very little incentive for someone because their process is going to cost more than the material they recover. And that's always been one of the biggest challenges in plastic recycling, is people have never been willing to put the hand in the pocket and pay for recycled plastic, because it's cheaper just to go and get some new oil out the ground and make new plastic.
Yeah, absolutely. I've got Ben, if I can just come back to you for a moment for the last couple of questions. I had two questions that seem to have an interesting connection to them, and Stephen, you might want to chip in on the latter of these as well. The first question is, do you think that the hydrogen/fuel cell and the existing engine communities can help the battery using community with the next level of safety needed for larger systems that can affect more people? After all, as you said, the hydrogen fuel cell world needs batteries to make good hybrids. So that's the first question about, can you get some of that support from other sectors in the safety world? And then John's added another question. Are there anti-synergies between battery and hydrogen safety? Obviously one would not want electric sited next to hydrogen tanks, but fuel cells and batteries are likely to be in proximity. So to what extent is this moving towards a safe, sustainable system, or to what extent are some of these pulling in opposite directions, I guess, is the overall question here.
Yeah, I'll do the second question first, because that's the easiest one. So from a system optimization perspective, then absolutely fuel cells and batteries very much want to be together. From a safety perspective, yeah, high voltage batteries and all of that high voltage power electronics around it wants to be very much separate. So we treat them as, we'll have a battery assembly subsystem, a high pressure hydrogen assembly subsystem, and a kind of generally low voltage, with the exception of the offtake, fuel cell, low voltage, low pressure high fuel cell system. So we treat them as completely separate things, and the twain shall never meet. And there's a fourth component, which is the passengers. So we think of those as separate, and we don't want them to go anywhere near each other. The danger is that people don't follow those rules, and that's the stuff I suppose I don't know if I was hinting, I'm fairly blatant about, is that people just go, well, it's all bits of an engine, it all goes in the engine bay, and no, that's just not right. Yeah, we didn't used to put the petrol tank in the engine bay, so why would you put the hydrogen tanks in the engine bay? So they have to be separate. So that's your what was the word? There was a clever word, somebody used anti-safety or something. The bit in terms of, kind of hydrogen fuel cell industry teach the battery industry anything? I don't know. But I mean, batteries are further along the commercialization path. So there's a lot to learn from batteries, I think. Batteries release hydrogen. Batteries release hydrogen and far more unpleasant HF and the like. So we should be able to learn some stuff from there. So yeah, maybe that question, I think, yes and no. Not an exciting answer. I'll stop there.
That's good. Things are not always that simple. Stephen, is there anything you wanted to add to that?
Yeah, well, obviously we've focused very much on the safety of batteries and how to make them safer, and I assume that work that we've done and a lot of other companies are doing at the moment, and a lot of standards which are in development, both for use of batteries in vehicles and use of batteries in aircraft, all that will then feed into those making hydrogen fuel cells and allow better regulation of the hydrogen. Therefore, I think they really work together. I don't think there's an anti-synergy there. I think anything developed safety in one industry should cross over to the next fairly easily, and everything we learn will pass over.
Great, that's really helpful. Thank you very much. Thanks both to Stephen and to Ben for your input, and thanks to everybody for adding your questions in the chat. I'm going to close the Q&A session now. I've covered most of them. I do realise there's a couple of people who didn't quite get their questions in. I apologise for that. John, I'm going to pass over to you just to do the commercial break for the next session.
Yeah, first of all, thank you very much to Stephen and Ben. That was really good. We really appreciate your engagement, and hopefully there are opportunities for everybody to follow up later. And the idea is eventually to have sandpits where people can meet over a beer or a coffee at these meetings. That's what we envisage. So many thanks to everybody for turning up, and we'll try and make things as smooth as we can going forward. In a month's time, we have another meeting. John Lowe from KEMIC, who, among other things, that develop materials for low temperature electrolyzers and fuel cells, will present, along with Manuel Hueca from AMD Power, who are developing lithium and sodium-ion batteries. So thank you very much for your time, and look forward to seeing as many of you as possible in a month's time.